Hello everyone. On this video we will be looking at how to find out the distance traveled using integration. Okay. Now remember the difference between displacement and distance. We covered that on the previous video. But to find the displacement, you integrate your function. But to find the distance, you integrate the absolute value of the function. Okay, so it's just a little bit different. All right. So just remember those two little tidbits of information we've gone over in past videos. Your absolute value definition. We have the absolute value of x is equal to x when your x is greater than or equal to 0, or negative x when x is less than 0. And you have your integral from a to b. You can break that down from a to some value c, plus the integral from that value c to b. Okay, so we're going to use both of those to find the distance. All right, so if you are still writing this, feel free to press pause, but we're going to go ahead and move on to our example. All right, so let's say for our example, which I wrote out already, we want to find the distance traveled by a particle if the velocity is given by the velocity function t squared minus 2t minus 15 from the interval t equals 2 to t equals 8. All right, so to solve this particular one, the first thing you have to do is find where the absolute value of your velocity function is equal to 0 in the interval. All right. Now it's the in the interval part that's pretty important. Let me see if I can clear that up a little. All right. So if we have the absolute value of t squared minus 2t minus 15 equals 0, if we factor that out as the absolute value of t minus 5 times t plus 3 equals 0, that means that t can equal 5 or t can equal negative 3. Both of those would make that equal to 0. Okay. Now, notice you're going from 2 to 8. You see here, negative 3 is not between the values 2 and 8. So we can't use that because it's not in the interval. Okay, so this is your C value. All right, so first thing we're going to do is use that as part of our absolute value definition. So we know that the absolute value of t squared minus 2t minus 15 is equal to our positive value. So you have t squared minus 2t minus 15 when t is greater than or equal to 5. And it's equal to the negative of that, negative t squared minus 2t minus 15 when t is less than 5. Okay, so if you remember from the previous video when we did the integral of absolute values, we pretty much use that same method. All right, so that means we take our starting function, so the integral from 2 to 8, because that's where we're going, from 2 to 8, of the absolute value of t squared minus 2t minus 15 with respect to t is going to equal the integral since we're going with less than 5, but we're only starting at 2, so from 2 to 5, we're using negative t squared minus 2t minus 15 with respect to t, plus, now we're going greater than or equal to 5, so we're going from 5 all the way to 8. So the integral from 5 to 8 of our positive t squared minus 2t minus 15 with respect to t. All right, so I'm just going to bring my equal sign over a little bit so I have a little more room, because we will need the room. All right, so we're going to go ahead here and just distribute the negative sign. So we have the integral from 2 to 5 of negative t squared plus 2t plus 15 with respect to t, plus the integral from 5 to 8 of t squared minus 2t minus 15 with respect to t. Okay. And then we go ahead and we just integrate each individual term. This can give us our negative t squared. The integral of that is t to the third over 3. So that's negative 1/3 t to the third. And the integral of t is t squared over 2. The two 2's would cancel out, which leaves us with t squared. So we have plus t squared. And the integral of 15 is just 15t, so plus 15t. And that's from 2 to 5. Plus, we have from, why am I rewriting that? T squared is just t to the third over 3, so you have 1/3 t to the third. Minus, again, you have t squared over 2, so that's just minus t squared, minus 15t. And that's from 5 to 8. Okay. And also, if you wanted to, you could have just factored that -1 out, and you would have just had the same values. But either way would have worked. I'm just showing you this way so you don't think, oh, if I forget to factor that out, it won't work. No, you could have factored that 1 out, and you would have had the same ones for each one, and it still would have worked. So, just something you can do on future problems. All right, so first we plug in our 5. So negative 1/3. So we have 5 to the third power, which is 125. So that's negative, really didn't need that, but negative 125 over 3. Plus, we plug in our 5. We have 5 squared, which is 25. Plus 15 times 5, which is 75. Minus, now we plug in our 2. We have negative 8 over 3. Plus 2 squared, which is 4. Plus 15 times 2, which is 30. Okay, so we did our fundamental theorem for this term. Plus, now we do it for this one, we plug in our 8. So we have 512 over 3, because 8 to the third power. 512 over 3 minus 8 squared, which is 64. Minus 15 times 8 is 120. Minus, plug in our 5. We have 125 over 3 minus 25 minus 75. Okay, so if we go ahead and combine those, and those, we end up with negative 125 over 3 plus 100, 25 and 75. And we distribute that minus, so it's plus 8 over 3 minus 34, because that would be plus 34, then minus. So minus 34 plus 512 over 3 minus, add those two together, you have minus 184. Distribute that negative and combine those two, so you have minus 125 over 3 plus 100 once you have that negative 100 and it's multiplied by the negative 1. Okay, so once you go ahead and combine all of your whole numbers and combine all of your fractions, you will end up with 270 over 3 minus 18, which will give you 72 as your final answer. All right, so as you can see, it's not a big difference as far as integrating to find the displacement. The only difference is you use the absolute value method when finding the actual distance instead of the displacement. All right, so hopefully this made sense, and I will see you on the next video.